right, so let's dive right in. So I'm going to give a talk on intelligent edge devices for the industrial Internet of Things. So I don't need to talk about this concept of this hyper-connected infrastructure that is being built. Right, we're connected through our devices to each other, and our devices themselves are being connected to each other, and items are getting smarter and smarter. But we've been working with many companies that are building out these systems today. I agree with the comments of the other speakers that we don't need to wait. Things are happening now. And the only way to learn is to implement and make progress. As we've looked at different types of systems, we find broadly they fall into two categories. Cyber-physical systems, where distributed control nodes are synchronized and coordinated and adapt and learn about each other and their environment, similar to the automotive example that Richard was talking about. And big analog data solutions. These are systems where a wide range of sensors are acquiring a great deal of data that is then analyzed to improve a process or to improve uptime or to improve overall quality of your systems. So let's talk about a classic analog data problem, condition monitoring. Now, in the industrial setting, this is a pretty well-known problem. But for those of you who aren't familiar with condition monitoring, I'm going to take just a minute to describe the concept. It's really pretty simple at a high level. What you want to do is monitor the assets you have out on your factory floor to prevent them from failing. You do that by acquiring a bunch of analog data so you know if a failure is coming, or better yet, to know what is the expected lifetime of that asset before it needs to be serviced. So you don't shut things down too soon, take things offline, and waste parts maintaining a piece of equipment that doesn't need to be maintained. Now, traditionally, condition monitoring was done mostly by walk-around systems. People walking around with measurement devices, hooking up accelerometers, or plugging into accelerometers that are there. An accelerometer is a vibration sensor, as you don't know. And taking data, maybe writing it down on a piece of paper or storing it on a local device and then doing some post-processing or maybe integrating it with other data if you're lucky. But the current trend is to move to more and more online systems where you take your critical assets and maybe even your less critical assets, instrument them not only with temperature sensors and vibration sensors, but adding things like thermal cameras, current measurements, voltage measurements, to gain more knowledge about the assets and also learn about the relationship of the two assets working together, or maybe multiple assets working together. Putting intelligence out there closer to the assets themselves to determine whether things are working properly, but also pushing data back so your expert maintenance people can take a look at that information and do additional analysis and determine what needs to happen out there on the factory floor, or maybe even an automated way, issue work orders for downtime and scheduled repair. Another example that we've seen is in the area of manufacturing. One of our customers that we work with is Airbus. Airbus has a Factory of the Future initiative where they're trying to improve the way planes are manufactured and assembled. They're trying to bring together the concepts of the human worker with robots and wearables. And I learned a lot I learned some things about building airplanes with our time with Airbus. One of the things that we learned is when a plane is assembled, 400,000 holes are drilled, and then over 1,000 tools are used to connect the parts together with fasteners. So doing that correctly with the right tools in the right place is a real quality problem. So what Airbus is doing is working to make the tools themselves smarter, to have wearables on the workers so they get information of what they should be doing, as well as coordinating with robotic systems and back-end systems to really assist the worker. It's very similar to us. When we drive to a location like this conference, we have to plan less because we have smart systems that help guide us to the conference through our GPS systems and directions. And there's even other driver assist issues or features coming in our cars in the future. Very similar concepts for the workers. And so they've built up a platform where they can use the same software technology and the same hardware technology in their tools and in their robots and in wearables to coordinate the work between the human workers as well as the automation systems. It's really pretty exciting stuff. And the thing I find incredibly interesting is it's fundamentally the same architecture as the condition monitoring solution. Where instead of assets at the end, I apologize that it's a little washed out here, you have, instead of assets at the end, you have wearables, robotics, smart tools, and sensors and actuators, not just sensors, communicating back to those same smart edge devices that coordinate with each other and also coordinate with back-end IT systems. Now, to pull this off, we believe that you need to have three fundamental components. First, you need to build on a platform. You can't start by building everything from first principles, right? You need to build on a platform that has good hardware software integration, that's modular and scalable. You also need to have an open architecture that's very IT friendly, as well as expandable by an ecosystem. So you're not doing all the work. And finally, you need to have a robust communication network that has low latency, high determinism, and synchronization. Now, at NI, what we're using is our modular automation platform, Compact Rio, along with our graphical programming environment, LabVIEW, that's riding on top of a version of Linux that we distribute, NI Linux Real-Time. And we're very excited about the work going on in IEEE right now around time-sensitive networks. We believe that we're right at the verge of having a converged network, where the days of the industrial buses will be a thing of the past, and we'll have a true converged network where everyone's equipment can operate side by side on the factory floor. Okay, so many of the concepts that I talked about here today came from a piece that I wrote for National Instruments 2015 Trend Watch. You can get that from ni.com, and there's 3 other trends that are also covered.